Okay, class. Now we're looking at lesson 9.4. Okay, here we're going to graph our points on the coordinate plane to solve real world and mathematical problems. So here we have hourly temperature. You know, when you watch the news and they tell you that it may rain by a certain time or the high temperature by a certain time of the day. Okay, so this is our real world type scenario when we speak of calculating our temperature by the hour. Now, on number 1, they're showing you to write the related number pairs for the hourly temperature as ordered. Okay, so we are finding that here in the 10 o'clock hour, the temperature is 8 degrees Fahrenheit. And so therefore, being that our time is our X and our temperature is our Y, then our X10, 8 would be our ordered pair, okay, at this first coordinate pair, 10, 8, X is 10, Y is 8. And so the next we would move here and here and here and here and so on and so forth. That's what we mean by our ordered pairs, okay, or related number pairs. And when 10 is related to 8 because at 8 o'clock, 8 degrees Fahrenheit is at 10 o'clock. And at 10 o'clock, this was the temperature. So these are related in that they correspond to each other, okay, within this time frame. So let's move forward to number 2. Number 2 says, what scale would be appropriate to graph the data? So now when we're speaking of a scale, okay, our scale, we're speaking of, we understand that a scale means the label or the distance, okay, the scale of numbers placed at a fixed distance. So if we went from here to here on our x-axis and from here to here on our y-axis, they want to know what would be a possible scale. So let's take a look. We see our lowest number for our hour is, it's 10 a.m., okay, which would be low. But our high would be 4 p.m., okay? So if we were to look at our clock hours, okay, we could say that we 10 to 11 is an hour difference, to 12 is an hour, hour. So they each are just an hour distance apart. So since they're just an hour distance apart, we start at 0, which is nothing, and we can end at 4, or we can actually end at 5, okay? So either way it goes, from 0 to 5, okay? We can show our hours. But when we look at our numbers from 8 to 41, and the difference between 8 and 11 is 3, and from 3 to 16 is 5, and from 16 to 27. So you see there's no consistency there. However, the numbers do increase, all right? So we can start at 0, of course, and we could stop, let's say 45, even 50 could be a possibility of us stopping, okay? And so our increments could be in the increments of 10 if we wanted, 10, 20, 30, 40, 50. Let's see how many number lines we have, 10, 20, 30, 40, 50. Or it could be in increments of, let's say 5, let's say 0, 5, 10, 15, 20, 25, 30, 35, 40. Okay, which would be 41 over here. It could be in, we've already stated 10, 5, okay, so whatever increments you want, but we know that we would go from 0 to 50 or 0 to 45, either way, 0 to 5 for the x-axis. So we say x, we would say 0 to 5, and then it would actually start 0 to 5 would we would say actually 0, and we would indicate 10 to 5, because otherwise we would think 0, 1, 2, 3, 4, 5, okay? So we would say 0, we would say 10, then 11, 12, 13, like that to 5, okay? Let's go ahead and write that out, okay? So we would say 0, 10, 11, 12, 1, 2, 3, 4, 5, okay? And then the other, the y-axis, we could say, we would start with 0, and we could say 10, we could say 20, we could say, I like it with the 5s personally, so I'm going to say 5, 10, 15, 20, 25, 30, 35, 40, okay, 45, okay? That's my preference, okay? Now, it says, what intervals? Now, the intervals are the distance between the values on the scale should be equal, okay? And so we've already indicated here from 0, 1, then 11, 12. So those are equal here, 1 apart. Here they're equal 5 apart, okay? And so that's how we would look at that, okay? All right, so then from there, let's take a look. Let's move forward with number 4. Make a line graph of the data. So let's take a look. If we say 0, okay, and if we start here at 10, 11, 12, 13, 1, 2, 3, 4, okay, that's our time, okay. Now we're going to look at our y-axis, okay, and so to look at our y, we would start at 0, and we would say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, okay. Then from there, we would do our ordered pairs, 10, 8, so when we're 10, we're 8, so it's 5, halfway, pretty much between 5 and 10, it would be about 8, okay? Then we would go from 11 to 11, so here's 11, and just over 10 would be 11. And then 12 to 16, here's 12, and just over 15 would be 16. And then from 1 to 27, here's 1, and just over 25, about halfway would be 27. And then from 2 to 31, so here's 2, we go 30, just over, be 1. And then from 3, we would say 38, so here's 3, and we go up to 35, about halfway would be 38. And then from 4 to 41, just about there. And therefore, we have our line graph, okay? All right, now, let's take a look now at number 6. So number 6, it says, between which 2 hours did the least change in temperature occur? So between which 2 hours did the least change in temperature? Well, we can look at our graph and see there's a big jump here and here, here, here. Well, because our graph is not specific right on the numbers and our points could be a little off, let's take a look up here. From here to here, the difference is 3. From here to here, the difference is 5. From here to here, the difference is 10, 11. From here to here, 27, 28, 29, 30, 31 is 4. From here to here is plus 7. And from here, 8, 9, 10 is 3. So it says between which 2 hours? So between 3 and 4 and 10 and 11, we only had a difference of 3 degrees. So our answer is from 10 to 11, okay? hours. Okay, and between 3 and 4 hour. Okay, and that's where we had the temperature. The change was 3 degrees. The change was 3 degrees. And so those are the 2 hours where we had the least amount of change. Okay, 10 a.m. to 11 a.m., 3 p.m. to 4 p.m. Okay? See you shortly.